Our lesson for today will be looking at chemistry 1502. The topic for today will be looking at IUPAC naming. Specifically, we'll be looking at another type of a functional group, which is ethers. Lesson 103. Let us start. Ethers, another functional group that we have. In order for you to understand ethers, you need to go through all the first few functional groups, so that you'll be familiar with how we came about generating the substituents, their names. Then it will be simple for you to understand the ethers and how to IUPAC name these types of compounds. And if you've went through the functional groups and know how to identify a particular functional group, then it will be simple for you to be able to identify ethers also. So the main basic designation of ethers is something like this. As usual, remember that the main aim of having this lesson videos is to make sure that a complex chapter or a concept can be broken down into simpler ways to understand it. So just try to identify this, or ethers can be easily identified using this formula, whereby R and this can be alkyl groups or aryl groups, meaning that we have this oxygen atom separating an alkyl, two alkyl groups or two aryl groups, or we can have alkyl and aryl group in one compound. And you should know that we have symmetrical ethers and asymmetrical ethers. Symmetrical ethers is when we have same groups from both sides, meaning that let's say we have alkyl alkyl, which are the same, or we can have aryl and aryl, which are also the same. And then asymmetrical ethers are the ones which we have different groups from both sides. But without wasting time, let us quickly review the alkyl. If you remember the alkyl, we've used them in a number of concepts or topics, also in mechanisms. Remember that we have CH4. CH4 is methane. And then we know very well that if we have CH3, which will serve as a substituent or attachment or a group, then we are going to have a methyl. And then if we have CH3, CH2, this is ethyl. The most common attachment that we are going to use in this chapter are the ones that I'm actually writing now. And then we have, I don't know if you remember this, but you should remember this. It's CH3, and then let us put 2 here. It's also a substituent, or we can represent it this way. So we have 1, 2, 3 carbons, and then this serves as an attachment. It's actually this line. So we know that this one will have 3 hydrogens attached to it, and also this one, and this one will have only 1. So you can see we have 1, 2, which is this one, 2 methyls, and this carbon, which is this one. So if you remember very well, this is isopropyl. And then we also have CH3, 3C. This is third. We've used this in a number of mechanisms. And then we have C6H5, which is phenyl. Now that we've reviewed the alkyl, let us relate it to today's topic. We are going to bring in a new term, which is alkoxy. its alkoxy group. In order for you to understand the alkoxy group, we are going to relate it with the alkyl groups. Let us actually use the very same page for you to understand quickly. For the alkoxy group, methyl, we have methoxy. Methoxy is when we have CH3 and then there's oxygen as a substituent. For the ethyl, we have ethoxy. By the way, it's methoxy. And then for ethoxy, it's H, we have CH3, CH2, and oxygen. For the isopropyl, we have isopropoxy, which will be CH3, CHO, and attachment. And then for tert-butyl, we have tert-butoxy, which will be CH3, CO. So you can see that we simply add our oxygen to the substituent. And then for phenyl, we are going to have phenoxy, which is C6H5O. So you can see that these substituents are the ones that make a compound to be an ether. Now let us get to the ethers. How do we name them, and how do we write or draw their Lewis structure? So let's say we have CH3, CH2, we have O, and then we have CH3. You can see that this compound, it follows the formula of this general formula. And you can see this is not a symmetrical ether. The reason why, the left hand side is not the same as the right hand side. On the left hand side we have the ethyl, on the right hand side we have the methyl. We have two ways to name ethers. We have the common name and the IUPAC name. To give names of ethers, it's simple. You simply identify the shortest or the shorter, smaller alkyl group, then it becomes your alkoxy substituent. In this case, you can see that comparing the left hand side and the right hand side, this part is smaller than the left hand side. So this will be our substituent, and then this shall be our, we can say, a parent chain. For the common name, we can see the left hand side we have ethyl, the right hand side we have methyl. Then this is our name. We follow alphabetical order. E comes first compared to M, so it's ethyl, methyl, and then the ending name will be ether. You don't have to join these names. So it's ethyl, methyl, ether, since we have this, or we can say this general formula. And then for the IUPAC name, the shorter, or let's say the smaller group becomes our alkoxy. That's what I said. We are comparing ethyl and methyl. Methyl is shorter than ethyl, so our methyl will be the methoxy. This is methoxy. Remember that from the alkoxy group, the one which I mentioned that we are relating it with the alkyl. We said CH3O is methoxy. So you can see the methoxy substituent is here. So our weight will have methoxy, and then our parent chain is ethane. So we combine the two, it will be methoxy ethane. Let us do another example so that you can get used to this. So you can say example number 2. Suppose we have something like this. Remember that you must also be used to the skeletal structures. So we have 1, 2, 1, 2. Let us put another one here. So you can see that we have two groups. Let us look at the left hand side. We can see that we have ethyl. The right hand side we have, it's 1, 2, 3. It's propyl. So in this case you can see that this will be our alkoxy group. So we are going to have, oh by the way, this is CH3, CH2, and then we have O. So you can see that this is ethoxy. It actually serves as a substituent, and then this will be our parent chain. And we can also draw this like this. And then we decide to put O, CH3, CH2. So this is a substituent, it's a branch. So in this case, we can say the common name, it will be ethyl, propyl ether. And then the smaller group, or the substituent, the smaller group will be ethoxy. Ethoxy propane. Let us complicate our structures a bit. Number 3, example number 3. Let's say we have CH3O attached to CH, and then we have CH3 here, and then we have CH3. If we were to draw a skeletal structure of this, we are going to have something like this. Let's just put CH3. Or we can put, for the common name, we can simply put this. So this part, it's a methyl, and then this part you can see it's isopropyl, isopropyl. Some say it's isopropyl. Then this is the name. We look at M and I. We know that M comes first, alphabetical order. So it's methyl isopropyl ether. So you simply put ether here. This is the common name. Then for the IUPAC name, this will be the substituent. The shorter, remember that the shorter group becomes our substituent. So we already know that we are going to have a methoxy. This is a methoxy. We have methoxy, and then let us look at the parent chain. We have how many carbons? We have 1, 2, 3. Even if we start from here, we are still going to have 1, 2, 3. And then let us look at the methoxy. Where is it attached to? It's attached to carbon number 2. So the position of the methoxy should be indicated. So we are going to have 2 methoxy, and then the parent chain is propane. So the name will be 2-methoxy propane. Let us complicate our examples more so that we can understand this. Example number 4. Suppose we have CH3 or CH3. We can see that it's actually a symmetrical ether. We don't have the small group whereby we can convert it to alkoxy. So we simply have methyl, ether, but we cannot really say methyl ether. We know that if we have two identical substituent, we can simply say dimethyl ether. And then for the IUPAC name, it doesn't matter which side we consider as the parent chain, which side we consider as the alkoxy group. So we can say it's methoxy, methane. Let us look at our last example. Let us complicate it further. So let's say we have this. This is our substituent, the small group, so it's our methyl. And then this, we can see that this is a third. It's a third butyl. And then the common name will be third butyl methyl ether. And then for the IUPAC name, we have to break it down. We have this substituent as our methoxy, but we have to position this methoxy. So we have 1, 2, 3, even if we can take 1, 2, 3, or let's say we take it this direction, 1, 2, 3, or we take it this direction, 1, 2, 3. We can see that any direction, doesn't matter the direction that we take as our parent chain, but we can see that the substituent, the methoxy, it's on carbon number 2. So the position of the methoxy is 2. And then we know that the parent chain will be propane. We have 1, 2, 3. On the very same second carbon number 2, we have our methyl. So methyl is on second carbon. Then the IUPAC name, we have to follow the alphabetical order. So it's going to be 2-methoxy hyphen 2 hyphen methyl propane. For the sake of understanding, let us quickly do the last one. For this one, you can pause the video, try to work it out and play the video to verify your answer. Suppose we have something like this. And then let us put a double bond here. Let us start by identifying the longest chain. Now the question would be, which priority are we going to take here, since we have the alkene and our alkoxy. Our parent chain should include this double bond. Alkoxy group can be a substituent, so it means our priority is this double bond. So we are going to have 1 2, 3, 4, 5, 6. We cannot start here. Once we start here, we see 1, 2. You can see that our double bond will not have the lowest number. Remember that IUPAC naming, we always aim for the lowest number possible. And then if we start here 1, 2, 3, 4, you can see that our double bond will be on the last, and it cannot be on the last carbon. So let us go straight to the IUPAC name. On carbon number 4, we have ethoxy. The reason why we say it's ethoxy, you can see that we have our first carbon is here, our second carbon is here. The attachment or the substituent, we can represent it like this. It's CH2CH3. So it's ethoxy on carbon number 4. On carbon number 2, actually on carbon number 1, we have our alkene. The parent chain is hexene. So on carbon number 1, we have our double bond. And then on carbon number 2, we have a methyl. Remember that the parent chain, it goes like this. So this is a substituent. Then on carbon number 2, we have our methyl. Then we have to rearrange this and put it in an alphabetical order. So the first part, E, comes first. So we have 4-ethoxy hyphen 2-methyl hyphen 1-hexene. We can continue, but we'll have to continue in another lesson video to avoid this lesson video being too long. That's it for this lesson video. This is Wahula SJ. Thank you very much.